If you look into the evolution process, this is something we have been missing in our equation, that we tend to use easy technologies. We tend to use technologies that can give us short-term benefits. But if you want to really look into the long-term benefits, the only best way is to mimic nature.
Bioreactor delivers simple starting substrates like water and CO2 to a monoculture or a mixed culture of Seneca cystis, which is a cyanobacterium. It's like a miniature plant. It takes the CO2 and water just like plants do, and it fixes that carbon dioxide into biomass. And if we can direct as much of that CO2 fixation into our fuel feedstock in an economically feasible fashion, and recycle as much of the nutrients as possible, then hopefully we can get a product that is competitive at large scale. The lights just really emulate what goes on outside. So with these benchtop systems, they're fully controlled and they're designed so that we can test or validate certain hypotheses before we go to larger scale. And have better control over the system. So these are like a mini pilot scale version where we can grow it a little bit larger than we would otherwise do in the lab, but much smaller than we would do in, say, a pilot scale photobioreactor. And we can control the light intensity, we can control the nutrient delivery, we can control the rate of mixing. All these parameters are controllable so that we can have a much greater control over our experiments in the lab and have greater predictability when we scale up the process. This technology takes solar energy and simple living organisms to do what nature does on a more rapid time scale in hopefully a way that we can use it at a relevant scale to what we consume.
So this technology actually takes carbon dioxide from the atmosphere and converts into the biofuel. So we are not adding any more carbon dioxide into the atmosphere, but we are using it in a way that is more sustainable to the human society.